When we talk about power in defense and aerospace, we're not talking about convenience. We're talking about survival. The ability to complete the mission, to return home, to maintain a technological edge. And at the heart of it all lies something small, cylindrical, and deceptively simple: the 1860-50 cell lithium-ion cell. The 1865 has been around for decades. Born in the 1990s for laptops, its name comes from its size, 18 millimeters by 65 millimeters. It became the workhorse of modern energy storage, compact, rugged, and reliable. While the consumer world moved to thinner, softer pouch cells, defense and aerospace stayed loyal to the 1860-50 cell. Because in the harshest environments, whether on the battlefield, in the stratosphere, or orbiting above Earth, simplicity and stability win. Today, this form factor has evolved beyond its origins. It's not just a battery anymore, it's a symbol of strategic independence. For too long, the United States depended on foreign suppliers for the very cells that power our weapons, vehicles, and satellites. That dependency is no longer sustainable for national security. At American Lithium Energy, we brought the 1860-50 cell production home. Designed, built, and manufactured right here in California, fully compliant with the National Defense Authorization Act. That means every cell is traceable, every material source is transparent, and every process is protected. We're not just building batteries, we're building sovereign energy capability. The same cells that power satellites, UAVs, and ground systems can now be supplied entirely within U.S. borders, from electrode to enclosure. It's more than manufacturing. It's about taking ownership of our energy future. In defense and aerospace, energy and power aren't just technical specifications, they are survival metrics. Energy density determines how long a mission can last. Power density determines how a system performs under extreme load. The 1865 form factor sits perfectly in between. It's compact enough for modular design, yet powerful enough for high-demand applications. At ALE, our 4 amp-hour and 4.2 amp-hour cells deliver up to 350 watt-hours per kilogram, while our power-optimized variants can discharge continuously at 20 C with bursts up to 30 degrees Celsius. That balance between endurance and performance is rare, and it's exactly what makes this cell the backbone of modern defense energy systems. Our architecture is flexible, scalable into packs, adaptable to different voltages, and compatible across ground vehicles, aircraft, and spacecraft. Whether the mission calls for long-duration endurance or instant high-burst output, the 1860-50 cell remains the most versatile cell platform ever created. This is more than a standard. It's a legacy of engineering excellence, reborn for a new era of American manufacturing. At American Lithium Energy, we've taken that legacy further, combining innovation with national resilience. Because when the mission depends on power, every cell matters. Now, let's shift from the strategic to the tactical, from the architecture of power to the realities of combat. Modern warfare pushes technology to the absolute limit. Batteries must endure ballistic shock, vibration, and temperature swings from the Arctic to the desert. A single failure can compromise a system or cost lives. At American Lithium Energy, we designed our systems around one rule: survive first, perform second. Our SafeCore protection architecture acts like a built-in fuse inside each cell. If a short or penetration occurs, SafeCore isolates the fault before it cascades, stopping thermal runaway before it starts. Even under ballistic impact or overpressure, our cells contain the event and prevent chain failure. That's what we mean by battle-tested engineering. Then there's Zero-Volt technology, a breakthrough that allows our lithium-ion cells to be safely discharged to 0 volts without degradation or corrosion. It means safer storage, simpler logistics, and longer shelf life, critical for deployed units and munitions that may sit idle for years before activation. Together, SafeCore and Zero-Volt define what we call safe power for the battlefield. They're integrated into our Safe 6T battery packs, which serve as drop-in replacements for legacy lead-acid and lithium systems. These packs deliver higher energy, improved safety, and true ruggedization for tanks, UGVs, and precision engagement systems. Each pack is military standard tested, Vibration, shock, thermal cycling, drop engineered for combat conditions, not lab benches. This is how American Lithium Energy defines readiness, through proof, not promises. Welcome back to the Watt Hour, powered by American Lithium Energy. In Part 1, we explored why the 18650 cells remains the strategic foundation of defense and aerospace power systems, a simple form factor that continues to shape how we build and deploy advanced energy solutions. Today, we move from the lab to the battlefield. This discussion isn't about efficiency or performance curves, it's about survival. How power systems endure heat, cold, shock, and even direct impact. Because in combat, power isn't just performance, it's protection. This is safe power for the battlefield. In modern warfare, energy storage must endure what no commercial battery ever could. A soldier's pack, a tank, or a guided munition operates in some of the harshest conditions on Earth and beyond. These systems face ballistic shock, relentless vibration, and temperature extremes ranging from sub-zero Arctic cold to desert heat exceeding 70 degrees Celsius. When a battery fails in that environment, it's not just an inconvenience. It can mean mission failure or loss of life. That's why, at American Lithium Energy, we design every cell, every pack, around one unbreakable rule. Survive first, perform second. Our mission has always been simple: to create energy systems that can take a hit and keep powering the mission. That's where our SafeCore and Zero-Volt technologies come into play. SafeCore is ALE's patented internal safety architecture, our engineering answer to catastrophic events like thermal runaway. Here's how it works. If a cell experiences an internal short or mechanical penetration, SafeCore acts as a microscopic fuse. It immediately isolates the fault, stopping the chain reaction that could lead to fire or explosion. It's not a concept, it's a proven system. SafeCore has been validated under ballistic testing, overpressure, and penetration conditions. These cells can take a hit, contain the damage, and prevent failure from spreading, even if the cells around them are compromised. That's what battle-tested means to us. It's not a slogan, it's a standard. Tested for survivability, validated for resilience, and built to perform under the most extreme circumstances imaginable. Our technologies redefine what it means to trust your power source in combat. Because when systems depend on stored energy, whether in a tank, a drone, or a precision weapon, you need to know that your battery will not quit before the mission is complete. It must withstand vibration, shock, and thermal stress while delivering consistent power output, no matter the conditions. SafeCore makes that possible. It turns potential failure points into layers of protection, and in the field, that difference is measured not just in performance, but in lives saved and missions completed. At American Lithium Energy, our focus has never been about building the most advanced battery for the lab. It's about building the most survivable power source for the warfighter. Power that endures, power that protects, power that wins. That's the standard we live by. Because in combat, the battery isn't just part of the system, it is the system. And when the mission depends on power, every cell matters. In our next segment, we take flight with flight-proven performance, how AL's high-energy cells are extending range, endurance, and reliability for UAVs, aircraft, and spacecraft. Welcome to segment 3. When people see a finished 18650 battery cell, shiny, compact, precisely engineered, they rarely think about what it took to create it. But behind every cell built at American Lithium Energy lies a story of chemistry, precision, automation, and American innovation. Today, I want to take you inside our factory to walk you through how our cells are made, from slurry to formation. It all begins with the slurry. Think of slurry as the lifeblood of the battery. It's a carefully balanced mix of active materials, conductive additives, binders, and solvents, engineered to become the positive and negative electrodes. At ALE, this process isn't art, it's controlled science. We use high-precision mixers under vacuum to eliminate air pockets, ensuring uniformity at the molecular level. The cathode and anode formulations, whether it's NMC, LMFP, or nanosilicon-enhanced graphite, are blended to exact viscosity targets. Every batch is sampled and tested before it ever touches a coating line. Because consistency at this stage determines everything that follows. Next comes the coating and drying process. The slurry is applied onto ultra-thin metal foils, aluminum for the cathode, copper for the anode, using precision slot die coaters. Our automation ensures film thickness uniformity down to microns across hundreds of meters of foil. As the coated electrodes move through our drying ovens, solvent evaporates and the electrode film bonds to the current collector. Every inch is scanned by optical sensors, verifying coating thickness, adhesion, and edge integrity. From there, the foils are calendared, compressed between rollers to achieve the right density and porosity. That's where we set the balance between power and energy. Denser films deliver higher energy. Slightly more porous films allow faster ion movement for high-power discharge. At ALE, we fine-tune that trade-off depending on whether the cell is destined for a UAV, a satellite, or a battlefield system. Once calendared, the electrode rolls are slit into narrow strips, wound into jelly rolls, and precisely layered with separators. This step, cell assembly, is where chemistry becomes structure. Each layer must align within microns. A separator just 20 micrometers thick must keep the electrodes from shorting while allowing ions to pass freely. The wound cell is inserted into its steel can, welded, filled with electrolyte, and sealed in a moisture-controlled dry room, where humidity never exceeds a few parts per million. Any trace of moisture could destroy the cell before it even forms. We use high-purity electrolyte filling systems and hermetic sealing processes developed for aerospace-grade reliability. Once sealed, the cells rest while the electrolyte fully wets the electrodes, preparing them for activation. And then comes the most critical stage, formation and aging. This is where each cell comes to life. During formation, we carefully charge and discharge every cell under tightly controlled voltage and temperature profiles. The goal is to create a solid electrolyte interface, a nanometer-thin layer that stabilizes the anode and defines the cell's lifespan, safety, and performance. Formation takes days. It's monitored continuously by automated systems that record every parameter: voltage, current, internal resistance, temperature. Each cell's digital fingerprint is logged and stored for full traceability. After formation, cells move to aging racks, where they rest for days or weeks. This step verifies that each cell remains stable, consistent, and ready for deployment. Any outlier, any cell that doesn't meet the exact curve, is rejected. That's how we ensure the cells that go into UAVs, submarines, spacecraft, and directed energy systems perform flawlessly. By the end of the process, each 186050 cell has undergone more than 100 inspections, measurements, and quality gates, from slurry to seal to full electrical qualification. When we say made in America, we mean it literally. Every roll, every weld, every test right here in California, built under NDAA compliance. This isn't just manufacturing, it's precision energy craftsmanship, performed at scale by a team of engineers, scientists, and technicians committed to powering missions that matter. At American Lithium Energy, we don't just build batteries, we build trust, we build resilience, and we build the energy foundation for a safer, stronger, and electrified America.
Need to power a drone, a ship, a satellite? Here's how to size energy like a pro from watts to megawatts. Watts equals volts times amps. Watt-hours equals how much energy. Kilowatt-hour and megawatt-hour equals scale. Amp-hours equals current capacity. Say you need 500 watt-hour for a UAV with 22-volt system. That's 22 volts x number of amp-hours, = 500 watt-hours. You'll need approximately 23 amp-hours worth of battery split across multiple cells. Energy cells are slow and steady, power cells deliver short bursts. American Lithium Energy makes both. Choosing the right type is mission critical. Fast charge, cold weather, long idle times, each factor affects sizing. This is where engineering meets application. ALE provides custom and commercial off-the-shelf cells engineered for performance across domains, from 0 to 80% in 20 minutes. Our cells are battle-tested and space-qualified.
As we close today's episode of the Watt Hour, I want to leave you with a deeper appreciation for what truly happens behind the walls of American Lithium Energy. When you hold one of our 18 6050 cells in your hand, you're not just holding a battery, you're holding the result of decades of research, precision engineering, and a relentless commitment to safety and American innovation. Each cell begins its life as chemistry in motion, slurry mixed to perfection, coated with precision, and assembled under the strictest environmental controls. It's charged, tested, and aged under conditions that mimic the most extreme missions imaginable. From slurry to formation, every detail is measured, every variable controlled. Because at ALE, quality isn't an inspection, it's a design principle. And when those cells leave our factory, they don't power ordinary products. They power missions. In defense, they drive armored vehicles, unmanned ground systems, and precision munitions where failure is not an option. In aerospace, they propel UAVs, eVTOL aircraft, satellites, and even lunar technologies that operate where no repair crew can go. In robotics and edge computing, they enable intelligent systems that think, move, and act independently, powered by energy that's stable, safe, and domestically built. Every one of these use cases comes back to a single truth. Reliable energy saves lives and advances capability. That's why we make our cells here in the United States, designed, built, and verified in California, meeting the highest standards of the National Defense Authorization Act. Our cells are not just products, they're strategic assets. They represent freedom from foreign supply chains and the assurance that America can power its future on its own terms. So when you see "Made by American Lithium Energy," understand what that means. It means innovation forged in safety. It means sovereignty through manufacturing. It means power that protects and performs, from Earth to orbit, from soldier to satellite. This is how we build. This is how we lead. And this is how we electrify Earth and beyond. I'm William Michael, Chief Strategy Officer at American Lithium Energy, and this has been the Watt Hour. Thank you for listening, and thank you for believing in the power of American engineering. Please hit the like button and please subscribe to our channel.